All right, here we are in section 2. So where were we when we finished off last week? Is we were on this unit click script here. So to use this unit click, this is an empty scene here. We need something in the scene. So I'm just gonna bring back just a basic object, a 3D object, this sphere. I happen to luck out that the sphere is in the camera view, but if you remember, we have this main camera. This is what the user is seeing, and if I click on it, it's sitting out in the virtual world. And when I click on it, you can see what's called the frustum, this big pyramid shape that shows you like the viewing angle, the viewing volume of what the camera sees or the player sees. And if you zoom in here, you can see like the sphere is within the big pyramid shape, and that's why we can see it as the player. And so if I click over here, we can see it. If that wasn't the case, you would move the sphere. What's also interesting to move it is move it in game view here, and you can like see where you're positioning it. So if it's getting off screen, you can bring it back. But either way, I just need to bring an object in. I need to look at it. If you remember, this is a scene full of game objects, and this game object has components. It's the components that are give it the behavior features. Each component is an object. We're in object-oriented programming. So you can think of each component as coming from a C# class. And these are all objects, and the game objects are, is 1 o'clock. Yeah. Okay. Yeah. So this is a game object, and it is also an object coming from a C# class. And game objects kind of hold all of these component objects, which are also objects coming from C# classes. And at the top here, just some like metadata relating to the game object, such as its name and some tags and layers, which we'll be getting into later today. And underneath here, if I just shrink these up, we have the transform dealing with this object's position, rotation, and scaling in the 3D world. This mesh information, which is used for like rendering it, computer graphics. Not really gonna get into this in this class. The collider is very important. We need a collider because the ways that we're clicking on stuff, eventually for creating or deleting these like painted objects, we rely on the physics system, and the physics system will shoot rays from the camera into the world to see, and it tries to hit colliders to see if like, oh, the user meant to be clicking on this. So on the sphere, I'm just going to bring this unit click script and connect it as a component object. And it is now instantiated. It is now an object. It is a copy of the class. And we can have many objects or many copies of class doing many different things. And I can double click on it to open it in Visual Studio. And if you remember 2 weeks ago, the ending before the quiz, we were spending a lot of time on this on mouse down method. So here we have our class, unit click. It's inheriting from mono behavior, which is coming from Unity Engine. And it gives us a lot of fantastic abilities, such as being able to connect as a component object to a game object, but it also gives us some methods that are really easy and to use. For example, on mouse down is a method that is called when the user presses the mouse button while over a GUI element or a collider. We haven't gone into UIs yet, so we're just focusing on colliders on 3D objects. This object we happens to have a collider. And it wraps up, or it abstracts away a lot of stuff that we're going to get into in this class, which is this stuff here. But it makes it very easy to be like, if you click on something, let's just print something out. So last week, or 2 weeks ago, we saw that we can print messages to ourselves in the console as a developer, and it helps us build our programs. And I'm clicking and nothing's happening, but I click on the sphere and I get a message, clicking and nothing, and click and there's more messages. Let me uncollapse it. And you can see multiple messages, right? So we're grabbing the name of the game object, printing out this hard-coded string, and then we're grabbing the position property of the transform component that's sitting on this game object, and we're calling the toString here, and that's printing out this nice little string right here. So if I pop over to the script, we've got the name of the game object, the hard-coded string, plus, which for strings we call concatenation or add, and we go into the transform, the position, and call it toString because the position is a vector3 class. It's like encapsulates 3 float values and has a lot of like helper functions for vector3 math that you don't want to get involved with. But at the end of the day, it's not a string. So how do we print to the console? Well, we use the toString method, and it creates a nice little text element, nice little string element of whatever these values are, as we see here. So as I ended section 1, it was really important to understand this keyword. This is like an essential idea with object-oriented programming, and it's referencing the objects that are coming from the classes. So this unit click script is a class, and it's a blueprint, and we don't actually directly use it. We copy it into an existence. In this case, it's copied as a component object on one game object, but I can take this game object and duplicate it, and now I've got 2, and they each have a unit click object. So both these unit click objects have this on mouse down method, and they're both looking out, like, am I being clicked on? Am I being clicked on? Meaning, is the user moving the mouse over me and then left clicking onto my collider? And in this case, I clicked on sphere 1. But if I go over here and click here, notice this is a different game object, different name with different coordinates. So we have 2 objects of type unit click. And so how do we distinguish which is which? So that's like, who is calling this method right now? There's 2 objects. How do we tell which object is calling it? Well, that's the this keyword. So whoever I clicked on, either this unit click object or this one, say, I don't care whoever you are, but I do know that you are a component object because you're of type mono behavior, and I connected you to these objects. We could have 3, 4, 5, it doesn't matter, it's all the same pattern. But I want you, this instance of unit click, go up. I know that you're like parented, you're only one component of this game object, or this one, depending on wherever the user clicked. But I want you to go up to your game object, look at its metadata, and go get me your name. So the game objects, so it's like this is like saying this, which I know is a component object because I wrote the script and I connected it. So it's some instance of unit click, and you are aware of your game object, who you're sitting on. The dot operator is like the member operator. It's like, go get me your member variable, your member property, called game object, lowercase game object, that's of type game object, that's referencing whoever you're sitting on. So for sphere, this unit click object, its member property is pointing at this game object. And this unit click object, its member property called game object is pointing to this one. So whoever your game object are, because there's multiple objects of type unit click, go tell me your game object, go into its property called name, which is a string, and then get it for me. Return it back. So ultimately returns this. And depending on which game object I'm clicking on, we kind of go up in our hierarchy from component object to game object, and we figure out which one we're sitting on. and then we concatenate with this hard-coded string, and then we go back into the this reference and go back up to your game object. Now go down into the transform component and go into its position property, which is of type vector3, and call the toString method on it. So this dot, 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 go here, go into this object, go into that one, ultimately call this toString. Ultimately, we're calling a method. So it's like saying go here, go up to the game object, because I know who you know that is. The game object is aware of all of its components, so go down into the transform. The transform knows of its own position. Go into its position, and then print it out for me. All right, so this is very important. And that kind of recaps where we were last week. Real good. Yep. So let's, let me stop Unity. And this idea of like parenting, or like a game object being responsible for its children, for its component objects that are giving its behavior. We also had this idea of parenting over here too. You can drag and drop game objects on top of each other and make complicated hierarchies. And one, it's for organization, which we'll see when we start building the user interface. And the other one is for kind of inheriting the transform of your parent. So you see that the sphere underneath is moving along with the parent sphere. So we kind of have this idea of parenting our children with the game objects, and parenting and children with the game object with its component objects. And this is known as like hierarchies or tree formations, and they're super useful to organize stuff in computer science. So I'm going to move off of on mouse down, and I can either comment out the code, or I could just put a return statement in front of the code. This basically says, hey, whenever this is executed, go down into here, but we just like return right away. We leave this block of code. In this case, this block of code is a function or a method, but you can also use this in like for loops and if statements and what have you. But I'm just basically saying, let's like invalidate this. Let's just not run this code. Let's just return right away. And so notice down here, I kind of have the same thing. And again, you could just comment stuff out, but I like to just pop in a return like that. So now basically this isn't running anymore because we're just returning right away. And now we're going to run down here. So if you remember, the update method is also coming from inheriting from mono behavior, which all of it is coming from the Unity engine library. And update is called every frame. So a frame is basically just like a unit, a small tick of time. It can be 30, 60, 90 times a second, frame rates, frames per second. And it's just how much your code can run as quickly as possible on the computer. So it's a variable amount, but it attempts to run as quickly as possible. And what it's really useful for is user input. So we're going to use it for user input, but you could use it for physics, which we're going to use a little bit. And it's also used for graphics. So here, if you notice, we're going into our update method. It's a block of code. And the first thing right off the bat is we have this if statement. So notice that the if statement is kind of structured like a method. You have your smooth brackets, and you have your input parameters going into it, and then there's this block of code afterward. So an if statement is whatever we pass in here needs to be a logical expression. It needs to evaluate to true or false, a Boolean. And if it's true, it'll run this code in here. And if it's false, it will not run this code. And if it's false, if we have like an else if or an else statement, it'll run this code instead. You don't need to have this. And if you have a more complicated logic situation, you could have, just many else if if you had to keep checking for stuff. And it'll just like go from one to the next to the next. And if it evaluates it, it does it. It runs that code and it stops. But here we just have an if statement. This is either true or false, and if it's true, we do this. So the update method is run as many times a second, and it's always just checking. In my case, it's checking for input. Most of the time, this will always be false. It's only true when the user presses the left mouse button. So what do we have here? This is the input class coming from Unity Engine, and it handles all input. So we can think of keyboards and mice and touch screens and game controllers. And we're gonna use dot operator. And we're gonna call a method on it, and the method is called, in this case, get key down. And this says it returns true during the frame that the user presses down on the key that you identify. So you have to pass in which key you want it to check for. And there's get key down, which is kind of like a click. And there's get key, which is true while you're holding down, so it's kind of like a drag. And there's get key up, which is only true when you release. So I guess one other thing to note is that we're calling the class directly. We're calling a method right in the class. And so this is what's called as a static method. We don't need an object of type input to call. You can think of this as it's like this master superclass about all the input systems. Unity built it, and you can go right to the class. We don't need to create objects of it because you're just really interested in referencing this. It's like you would have one object of input, or if you're never going to have objects of input, you can write the code and it can be called right from the class. So we make objects because we create many objects, like all these little objects that we're painting. But since this is kind of like a super class, like a meta class, they just wrote the code right in the class, and this is what's called a static method call. A static method. We're calling the method that's sitting right on the class. It's actually not instantiated as an object, and we're just running the code in the method. So now what we pass in here is got to be something. If you read it, it says type key code enum. So enumerations are really important. They're a little bit different. So we've talked of primitive types like integer, boolean, float. We've talked about, which are also classes, but we call them primitive types, and those are provided to you from the base library of whatever coding language you're in. And then there's classes that you're creating yourself and you're creating objects from, and then there's classes that you're importing from libraries. So our Unity engine, we're dealing with game objects and vector3s, and here we have rays and raycast hit, which I'm going to cover in a minute. But these are more complicated classes that objects are coming from. But something that's a little bit unique is something called an enumeration, which is a list that maps strings to integers. So text that humans can read mapping to integers that computers can read easily. So as I hover over here, this key code.mouse0 says it's equal to 323. And it's referencing the left or the primary mouse button. So I'm passing in, I'm saying, hey, input class, I want you to tell me true whenever the user presses the left mouse button. So I had to pass in this mapping, this list. It was a list called a key code. And I said within the list, I want the element, which is mouse 0, which is referencing left. This gets evaluated to an integer. It's a mapping from a string to an integer. And behind the scenes, it's 323. But I don't even need to know any of that. So first off, let me just get rid of that and just say key code dot. And here's the big list because we use IntelliSense. Visual Studio can look stuff up and help us out. And this is every key, keyboard key, a joystick button, and mouse button listed out. It's whatever you want. Somebody sat there and wrote this all out and made it to other developers. A Unity developer did this all up. So it's really easy for you, a third-party developer, to tell your Unity code what key or mouse you want to use. Yeah.
So mouse 0 will always reference the left.
So if I type in like mouse 1 and I hover over, that says that's the right mouse button. And then like mouse 2 is the middle mouse button. But this is like a type called enumeration, and you create them and you define them yourself. So I'm saying, hey, I want to reference key code, which is something, a list of type enumeration that somebody else made. And I'm just saying I want that element, and I'm passing it in to this method. But if I go to definition on key code, it actually opens up a C# file from the Unity engine library. So we're like peeking into the code that Unity developers have written. And notice how it's saying, okay, it's defining, it's saying, hey, we're in the namespace Unity engine. And there's a big curly block, a block of code. And if I go all the way down to the bottom, here's the ending of it. So it's just a big block of code and saying we're in the Unity engine namespace. And then the only thing it says is, hey, we're going to have a public enum. We're going to declare it called key code. And its enum is just like saying, I'm going to define a list, and I'm going to call this list called key code, and other people can reference it because it's public. And so notice again, the list starts here. We have an open curly bracket, and I go all the way down, and there's the ending of it. So it's a huge list. And as I move through it, it's just specifying strings, and they're equal to numbers. So backspace is equal to this. Delete is equal to that. That's just a hex code. Don't worry about it. Tab is equal to this. Clear is equal to that. You don't have to specify the integer. If you don't, it'll just assign it a random number. That's not what's important. I mean, for them, the actual number meant something. I'm guessing because it's a hardware thing. So like they really want to hard code the numbers in. But what's important is that they're listing out string values, text that's easy for people to understand, and it's being associated directly with a number or indirectly with an integer number if you don't declare it explicitly. But this is a big list. Someone sat here and did it so that you don't have to, you're giving a list of options. So enumerations, very important. And you can think of them as lists of mappings from string to integers. And it makes it very easy for me to say, hey, input class, I want you to let me know when the user presses the left mouse button. Because I'm passing in the enumeration element from the enumeration key code element mouse 0, and their code can figure out everything else. Cool. So the next thing that happens is we're going to grab the camera class from Unity Engine. We're going to use a dot operator. We're going to go in and get its property called main. And this is the main camera in your scene. So every scene has to have a main camera. That's what the user is looking through. And main cameras are tagged as main camera. So there's a few different ways to hunt around and find game objects in a scene. One of them is trying to find them by their name. And another way is to find or look up game objects that have a tag on it. This is a really quick way because you can tag multiple game objects with a tag. And at runtime, it's just like a little collection. You can just say, hey, tell me everything that has this tag on it. And it'll just send you a collection of game objects. And then there's also layers, which we're going to get into more. The physics system. It's like a way to filter out different colliders in the physics system. So ways we can check for game objects are names, tags, and layers. But we need a main camera tagged as main camera. And sometimes when I've noticed in the past, some students they start their Unity and this isn't tagged as main camera for whatever reason, or they switch it off and this breaks the script. Just make sure this is tagged as main camera, because that's what this is looking up. Once you have the camera, it's saying call a method on it called screen_point_to_ray. Now this is the actual camera component. So this is main camera is this game object. It has a few different parts on it, or components, objects like transform, camera, and audio listener. And the camera component, remember, is an object from a C# class. So you can call methods from it, and that's the method that we're calling. In fact, you can go up here and this question mark, and it'll bring you to the Unity manual, and it's actually talking about the camera component, like describe what's happening and give you an idea of it. And this is the manual, kind of just talking about a lot of stuff. And then what you want to get familiar with is the scripting API. So if I say, okay, switch to scripting, this is the camera component. If you remember, it's just a C# object, which has properties and methods. So it's like you can look up what you can call on it. So remember static stuff, you have static properties and static methods. These are things that are useful to call right onto the class. And usually what we use are just properties and methods. And that's like specific to an object, an instance of the class. And properties usually have a value or some type of object associated with them. And a method is a function that we can call on that object. So what were we calling? ScreenPointToArray. So I'm just going to look it up. And here's the method, ScreenPointToArray. Returns array going from the camera through a screen point. And you can click on it, and you can even get like the method declaration, the input, the return statement. You can even get a description and like an example, which is usually super useful. So what ScreenPointToArray is doing is, if you look at this camera is sitting out in this virtual world, in a 3D world. It's got 3D coordinates of where it's positioned and where it's looking. But if you zoom into it, you'll see that there's like this little rectangle starts off on our pyramid, and this is like the user's screen. This is what they're seeing out into the world. So when you go into game view, and you think about the user moving their mouse position around, and we're in the screen, we're on the user's monitor, we're in pixel space, we're dealing with 2D coordinates, x and y, x for left, right, y for up and down. And we want to know where this mouse is moving in this screen space. You can think of the screen space as this little rectangle here. So as the mouse is moving, when you translate from the user's monitor into your virtual 3D world, you could think of it, this little rectangle here, as this is what our starting point is. This is our screen space. And as we're moving the mouse around, when we like read in the mouse position, it's like, where is the mouse in this rectangle? And so this is what this input.mouse position is. As I hover over it, it's like the current mouse position in pixel coordinates, so x and y. So if we send this in to our ScreenPointToArray, you can think of array as a vector that's specific to the physics system. So a vector can be, it contains floats. Sometimes there's vector 2s, which are good for 2D space, vector 3s, which are good for 3D space because there's 3 floats, and then we have vector 4s. For us, we use them for colors. But we could think of this screen space to ray. It's going to shoot a ray out. So wherever the user is moving their mouse in this rectangle, we're going to shoot a ray out in the direction that the camera is looking. So you can think of it like shooting bullets from a gun. And it's going to shoot out in this pyramid shape. It's going to shoot out and see if it hits something. So these little spheres, when I hover my mouse like right there, like where the user would hover the mouse right there, you could think of it as almost like it's kind of in this part of this little rectangle, and it's shooting a line out into 3D space, and since it was aligned with the sphere, it's going to hit the sphere. Like your gun was aimed at the sphere, we shoot a ray out, and we're going to hit the collider on this sphere. So since we're going to be using the physics system, it's really important to understand that if we want to know if we're hitting something, it needs to have a collider on it, which makes it part of the physics system. So we take in this update loop, which is running many times a second. If the user clicks, then we say, okay, where on the screen did they click? And then go take the main camera and use this method to shoot a ray out from the screen point out into the world, like shoot a bullet and see what its trajectory was. And then we have to store it because we reference it later. So we create a variable of type ray, capital R, that's the class. And we're creating a variable of that type, that's the lowercase r. And we're storing this ray that we're generating from shooting out from the mouse position out in the direction that the camera is looking into the 3D world. And we store that. And then we also have to create an object of type raycast hit, because that's the hit information. Like if we do get a hit, what did we hit? We're going to record it onto this object called hit. And as I hover over raycast hit, notice it is coming from the Unity engine, but it's of type struct. So as I hover over, well, ray is a struct too, but if I hover over input, you see it's of type class. Most of the time we've been dealing with classes. Now these are just structs. Now a struct is like a simplified class. It's just a class without methods. It has properties. It just has data. So most of the time you'll see that stuff is classes. But in object-oriented programming, we also have stuff called structs or structures. And they just contain a lot of properties. They just contain a lot of data. So now, once we have our array going out from the camera, from our mouse position, and we have this hit structure that we record information on, we can then use the physics system. So it says if, let's call the physics class. And again, this is a static method call. There's no physics object. There's just kind of like this super class, or what they're calling a global, like a global class. And we're calling this raycast method. And if you wanted to, you can look this stuff up in the scripting API and get examples and read more about it. But this will shoot a ray out and record any hits with colliders. So we have to pass in the ray object that we created, and we pass in the hit, or the raycast hit object that we just created. And notice that there's this out keyword. But in either case, these are inputs going into the raycast method, and then all of that is passed in as an expression into this if statement. And so if this says false, I didn't hit anything, we don't not evaluate. But if it's true, it says, yes, I hit something, then we do evaluate. Now, if it's true, this returns true. It returned a Boolean. How do we know more information about what we hit? The problem is this method was designed to just return a bool. And then that's what this out keyword is useful for. It's like we have more information coming out. It's like we're passing something in as an input parameter, but we're allowed to edit it within our method code and return it back out with new information, with new data. So it's like an alternative way. Like if you have a return type, but you still have like more stuff you need to return, here's like an alternative way. It's called out, and it's for editing input and being able to send it back out. So if this is true, then we are allowed to evaluate this. So I only did this check because I had multiple objects like sitting. This code makes more sense like sitting on one object by itself, but I had like multiple spheres that were running this. So I had to say like, hey, whichever sphere is actually named the same as what was written onto this hit target, then I know that you are the one that the user hit. But what's really important is that this, notice that this debug.log is very similar to this up here. But instead of this saying, hey, you are reporting yourself, we're checking the hit target. Okay, physics said we hit something. Let's check what physics said we hit. It's this structure, this raycast hit, which is like giving us information. So go to the hit information and let's look up. You have to grab stuff through the transform with it. But this code ends up being the same as this up here, except we broke out everything like user input and using the physics system. And so I had to sit there and explain that all what's happening and give you a better knowledge of how this is all working before we get deeper with the code. So if I click play with that, if I click here, we're saying this sphere was clicked, and if I click over here, we're saying this sphere was clicked. So it's like the same functionality of this unit click. It's just instead of this one line of code, we're breaking it all out and we're having to understand another level deeper of everything. All right, so there's a lot was compressed into this that I had to cover. And I'm gonna actually stop the video here and start another one. Anyone have any questions if they have them?